This recording is going to take a bit of a different structure. Instead of doing math, that is calculations, I'd like to spend some time talking about a graph. This is a YouTube recording instead of Pencast. So I'm going to be discussing question 14 from chapter 2. You can see it displayed here. Let me just read it and then talk through the different parts. So, figure 2.14 is the velocity versus time graph for an object moving along the x-axis. Note this is velocity versus time, not position versus time. Velocity. Part A, during which segments is the velocity constant? I find it convenient for this question to, in my mind, replace the green line with a bunch of small dots that are kind of closely spaced together. And then I can change this part A question to when do the dots represent the same number. For example, in segment A, the bunch of dots would all represent a velocity of 2, which means the velocity isn't changing, it's constant. So part of the answer is segment A. During segment A, the velocity is constant. During segment B, in contrast, the dots would represent first a velocity of 2, then say 1.9, 1.8, 1.7 on down. And so because those velocities are different numbers, the velocity is not constant. Similarly, for segment C, the velocity is changing. For segment D, however, if you imagine replacing that segment with a bunch of small dots, each dot would represent a velocity of -2. So during segment D, the velocity is constant. During segment E, it is not constant. And during segment F, if you imagine replacing the line with dots, all the dots would represent a velocity of 0. And because all the velocities are the same, the velocity is constant. So the final answer for part A is segments A, D, and F. Okay, part B. During which segments is the object speeding up? A bit of a note here. In physics, there's a difference between speed and velocity. Velocity is, as I defined it in class, and can be positive and negative. Speed is the absolute value of velocity. So speed is never negative. The lowest speed you can have is 0. Okay, so speeding up means moving faster. It doesn't matter if it's right or left. So during which segments is the object speeding up? That means that when is the absolute value of velocity getting to be a greater and greater number? Well, during segment A, it's constant. During segment B, the velocity is going down, the absolute value is going down. During segment C, however, if you imagine replacing the line with dots, we would start at 0 and then have -0.1, -0.2, -0.3. If we then take the absolute value to get speed, those numbers would be going up. So during segment C, the object is speeding up. And then D, E, and F, the speed is not speeding up. So the answer is just segment C. Okay, part C. During which segments is the object slowing down? So this is when the speed is getting to a lower and lower number, closer to 0. So during segment A, it's constant, so no. During segment B, the velocity is getting to be a smaller and smaller number, so the speed is getting to be smaller and smaller. That is, the object is slowing down. And then similarly, so C, it's speeding up, D, it's constant, and then E, the velocity is going from -2 to -1 to 0. So the absolute value is going from 2 to 1 to 0. That's slowing down. So during segment E, the object is also slowing down, and during F, it's constant. So the final answer for part C is segments B and E. Okay, part D. During which segments is the object standing still? So standing still means the position is not changing. A better way of thinking about it, or more straightforward way of thinking about it in this problem is, when is the velocity 0? When the velocity is 0, it's standing still. And there's only one segment where the velocity is 0. That's segment F. And lastly, part E, during which segments is the object moving to the right? So the traditional definition that we will use almost all the time is for the x-axis, to the right is positive, to the left is negative. So the object is moving to the right whenever its velocity is positive. So If you replace the green line with a bunch of dots, you want to look for all the dots that are positive. And so segment A, it's always positive. Segment B, it's positive. And then D or C, D and E, it's negative, and F, it's 0. So the only dots that are positive are in segments A and B. So that's the only time the object is moving to the right. Okay, let's stop there.